supposed to have 4 days of 3.13. I canceled the 4th day, so we'll start 3.14 tomorrow. So day 4 of 3.13, don't worry, that material is not on the AP exam anyway, so I made an executive decision to cut it. It's cut. Okay, so tomorrow we do section 3.14, and then Thursday, day 2 of 3.14. Friday is a work day. It's a homework check day. It's a day where I go over the Polar poster project for you and give you time to work on it if you want to start working on it. And that project is a quiz grade. It's going to help a lot of you with the other quiz that we didn't do so great on. And that project is on tomorrow and Thursday's section. So you have to know how to do section 3.14 to do that. So if you're absent tomorrow or Thursday, please make sure you watch the video to get caught up. I heard a rumor that my last couple of videos, just like last Thursday and Friday, they're blocked again. I do have a work order in. They're working on it right now. So hopefully it gets resolved quickly again. I don't know what's going on, why it's happening. So remember, if you do have some kind of a problem watching a video, as long as you watch it on a non-school device until they fix it, you can still see it, all right? You can watch on your phone or like your own personal laptop, but for some reason, the school laptops have been blocking YouTube unless they fix it. And they fixed it, but now it's not fixed. So whatever. All right. So today's lesson is very similar to Friday. So if you weren't here Friday, you're kind of getting Friday's lesson, and you might be a little behind on some of the things I'm talking about. But let me read to you. We are in a section where we are working with complex numbers again. Complex numbers we've talked about before, and you've talked about in Algebra 2 and maybe even Algebra 1. Complex numbers are real and imaginary numbers in the same place. So we talked about imaginary numbers in this class way back in Unit 1 when we'd have like a negative under the radical, like in quadratic formula, and we'd have an I in our answer. And complex just means you have a real and an imaginary number together. And it's in this form, A plus BI. So they're introducing a new letter, Z, equals A plus BI, where A is the real part and the imaginary part is BI. So A and B are just numbers. And then B just is a number, B is a number, with an I next to it, which just means it's the imaginary part of the problem. And the first thing we're going to do is graph some imaginary numbers. These are freebies. These are the easiest thing. No one's going to struggle with these at all, okay? So in this new little complex number setup that we have here, A and B are numbers. And you can think of them as an ordered pair, the same as you would think of X and Y. So the very first thing, huge key point of today's whole lesson is that A and B and X and Y are interchangeable in like every situation. A and B are just two other ways that we can call X and Y, okay? So when you see an imaginary or a complex number written like this, you can just think of that. A is 3, B is 4. Think of it as an ordered pair, 3, 4. And you graph it the same exact way. If you look at the graph, we have a horizontal axis and a vertical axis like we always do. And they're calling this the real axis and this the imaginary axis. So you go left or right A, up or down B. So 3, 4 would be to the right 3, up 4. There's point A. Okay? This would be -4, 0. So that would be to the left 4, up or down 0. Right? So these are just ordered pairs. Let's just do one more. We don't need to do a whole bunch of these. 0, 2, that would be right here. So being able to graph a complex number, first important skill. Okay? You get that? A, B is just like X and Y. I need to do another one. -1, -2, A, B, -1, -2, that would be point F. Do you see it? Yes. B? Oh, I don't know. Is that why you guys weren't answering me when I said? Okay. Did I not graph that one last period? I did it last period too. No, I didn't. I don't know. I'm so sorry. That is not B. Thank you, Haley. Guys, tell me when I make a mistake. I know it's so rare that it catches you off guard, but when I do, you should tell me when I make a mistake. 0, 2 would be up here. I apologize. Are the other ones okay, Haley? Okay. Sorry about that. Thank you. Are we good now? Do we understand? Do you understand? Okay. All right. So what we're going to do is make some connections between all these right triangles. We have drawn so many right triangles on all 4 quadrants of the unit circle. We've done Pythagorean theorem 5 million times. We're back to doing it again. What I'm going to do is I'm going to draw a right triangle in quadrant 1 right here. Okay? Same right triangle we've drawn a million times. In geometry, you called the sides of a right triangle A, B, hypotenuse C. Think about Pythagorean theorem, A squared plus B squared equals C squared. Then we got into trig, and I taught you on a right triangle, we called this cosine x, sine x, and on the unit circle, all of your radii are 1, right, unit circle, so that hypotenuse is always 1. And we had that Pythagorean identity, cosine squared x plus sine squared x equals 1 squared or just 1. Friday of last week, we had right triangles. Let me put those thetas in there in the right places, sorry. On Friday, we called this x, y, and r. And today, I'm going to call it A, B, right? That's what we just learned about, to the right or left A, up or down B. That's that ordered pair, A, B. And they're giving this hypotenuse, radius, a new letter, and I'll explain that in a minute. And I'll explain that in a minute. I know I just said that 3 times, but what I want you to make a connection about is that all 4 of these right triangles really mean the same thing. You could interchange any of those sides. It all means the same thing. You should be able to look at any right triangle and identify the legs and the hypotenuse and call them anything you want. Call it George, Sam, and Joe. It doesn't matter as long as you know what the relationship is. In any of these triangles, I should be able to do SOHCAHTOA, opposite over hypotenuse, or adjacent over hypotenuse, using whatever you call it, okay? You should be able to do Pythagorean theorem, knowing the 2 sides that make the right angle are my legs. Whatever you want to call them, it doesn't matter. And then the hypotenuse is that longest side, okay? But just know a right triangle is a right triangle is a right triangle, okay? So I just explained to you above why these 2 sides get called A and B, but where did the absolute value of Z come from? Well, it comes from this. And where did this come from? That should make you think Pythagorean theorem a little bit. It's just the advanced version of it. It's like taking your A squared plus B squared equals C squared and just changing it a little bit. It's saying that, so remember, we just learned Z equals A plus BI. If I did Z squared equals A squared plus B squared, and then just took it 1 step further and did the square root of both sides, I would get Z equals the square root of A squared plus B squared. This is Pythagorean theorem, right? Now we can just plug in the A and the B and square them and find the square root. Where did the absolute value come from? Well, absolute value just means positive, right? Z is always positive, which we already know. We talk about it all the time in this class. The radius, the hypotenuse, it's always positive, always. So that's all that means. Don't overthink it, okay? Also, we need to talk about this formula. Don't worry about anything else. How many times have we talked about tan? We have called tan sine over cosine. We have called tan y over x. And now we're calling tan b over a. All of them mean the same thing. They all mean the same thing. It just depends on which triangle you're looking at. It's still b over a, sine over cosine, y over x, opposite over, opposite over adjacent, o over a, right? Opposite over adjacent. So here's what I really need you guys to cement into your brain. A and B is interchangeable with what? X and Y. They mean the same thing. And where we're taking this is that last Friday we talked about anything that has X's and Y's in it is rectangular, and R's and thetas are polar. Same idea. Anything that has X and Y, or A and B now, because they're interchangeable, are rectangular, and R's and thetas are still polar. So we're doing exactly what we did last Friday of going between rectangular and polar form. The only difference is now there's an I involved, and instead of X and Y, we're calling it A and B. Let me show you what I mean in example 11. So it's asking for three things. Find the absolute value of Z, which is also known as the radius, which is also known as the hypotenuse, which is also known as C. Call it whatever you want. Just know what it is. And theta. So we have to find these two things. And we're going to graph on our little graph here this new type of graph. That's a complex number. So we can think of this as an ordered pair, just like we did in the first example on the page before. How do I know that -7 is the B? Because it's got an I attached to it. B always has an I attached to it. There is no A value, so we would call it 0. We saw it written a little bit differently on the other page, right? They actually put the 0 in. You could see it like that, or they could have written this B just as B equals 2I. That means the same thing, or B equals 2I. So if there is no A value, it's 0. So those two mean the same thing. All right, so let's graph first, because I think that makes things easier. So if I graph 0, -7, I'd go left or right 0, down to -7. There's that point, right? Graphed. Did the graphing. Now let's find the absolute value of Z. The absolute value of Z is just Pythagorean theorem. A squared plus B squared. Absolute value of Z is 7. And then to find theta, we're going to use y over x, b over a, sine over cosine, whatever you want to think, or sine over opposite over adjacent, sorry. Tan of theta equals b over a. Y over x. Whatever. Anytime you have a 0 in your denominator, we are undefined. So the question is, what theta on the unit circle, right? What theta on the unit circle do we get a tan of undefined? Well, we know our denominators of 4, 6, and 3 pretty much by heart. Undefined and 0 are your quadrantals. Tan is undefined at the top and the bottom, and tan is 0 right and left. Okay, so we are undefined at pi over 2 and 3 pi over 2, and tan is 0 at 0 and pi. Either memorize it or remember y over x and simplify. So which one are we going to use? How do we know if we're going to use pi over 2 or 3 pi over 2? Because tan is undefined at each of them. Remember what we learned last Friday? Which one do you think we're going to use? 3 pi over 2. Zach, you're really getting this. Thank you. 3 pi over 2, because what we learned last Friday was a big concept on Friday, is that whether you're in rectangular form or polar form, they're just two different ways of traveling to the same place. So same idea. This was rectangular. A's and B's and X's and Y's are rectangular. That point was right here. Well, when we switch to polar, which is, this is also known as R, R's and thetas, we're also in the same place. So my polar point is in the same exact point as my rectangular point, so that's how Zach knew to do the 3 pi over 2. So we found all three things. We graphed, found Z, also known as R, and theta. what we're going to do now is put all of it together, just like on Friday. Guys, I hear some talking. You should be paying attention. Just like on Friday, we were given, okay, look. We were given 1, 2, 3, 4 formulas. We use these to convert between rectangular and polar form. And if you remember, I kind of squeezed in like the why of it all, like how we got those by using the right triangle. But you never had to recreate like why that. You just had to know the formulas. We're going to do the same thing. Let me start by drawing another quadrant 1 right triangle, just because it's nice and easy. That's why we keep using quadrant 1. And don't forget, this is A, this is B, and on the page before we called this the absolute value of Z. I'm going to call it R now. Why? 2 reasons. 3 reasons. Because I want to, because I can, and because I'm going between rectangular and polar form. What does polar always have in it? R's and thetas. So instead of using C, instead of using the word hypotenuse, instead of using the absolute value of Z, all those different things we called the hypotenuse, for the purpose of this problem, it makes sense to use R. They're all interchangeable, okay? So I'm going to use R because it works best for polar form. So if I use this triangle and identify what cosine is A over H, right? That would be adjacent, which happens to be A in this picture, and then over my hypotenuse in our picture is called R. And then remember what we did. We got the A by itself, except on Friday, instead of an A, what was that letter? Instead of A right here, what did we have on Friday? X. X equals R cosine theta. Why is it A now? Remember, A and X are interchangeable. It's the same side of that right triangle, okay? Sine in this picture would be opposite over hypotenuse. Again. So B equals R sine theta. What was B on Friday? Y, right? B and Y are interchangeable. It's the same exact thing I told you on Friday. Now what we're going to do, and you never have to recreate this, I just want you to understand where all this stuff comes from. Now I can substitute in, because this is rectangular. Again, how do I know this is rectangular? It's got A and B in it. A, B, X, and Y. Any of these letters mean you're rectangular. We're going to change it to polar form. What's always in polar form? R's and thetas. So all I'm going to do is take out A and take out B, A and B, and substitute in what those are. So Z equals, I'm going to take out the A and substitute in R cosine theta, plus take out B and get R sine theta. Don't forget there's an I in there. You can put the I at the front or the back. I'll be honest with you, it's normally put in the front, but if you put it at the back, you're not wrong. And we're in polar form now, right? There's no more ABs, X's, or Y's. We have all R's and thetas, but there's one last thing we do just to clean the problem up a little bit, and that is we factor out the R and put whatever's left over in the parentheses. So R pulled out of both times cosine theta plus I sine theta. This is what we're going to be doing, changing from rectangular form to polar form using all of the stuff I just taught you. So let us do our last 2 examples, which will show you exactly what your homework is like on the next page. Let's go to example 12. All right, so we are given a complex number. Review. Complex just means it's got an I in it. Complex. This is clearly rectangular. okay, with an A and a B in it. And we're going to write it in polar form. So what we have is rectangular form, and we can pull out the A and the B if we wanted to. So remember, I is just a variable. If there's no number in front of a variable, it means it's 1. Now, in the notes here, they're having us graph it. You're not going to have to graph it in the homework. You don't really need the graph to be able to go from rectangular to polar form, which is what we're about to do. But it does, what you do need to know is what quadrant this is in, okay? And without graphing it, I would like you to notice that even though you don't know what the square root of 3 is, I mean, you could put it in your calculator and see that the square root of 3 is 1.7 something, okay? But that doesn't even matter. If it's a positive number, we go to the right, and then the second number is positive, so we go to the right and up. So I don't think it's a stretch of the imagination for you guys to figure out that we are in quadrant 1. This guy is in quadrant 1. That's really all you're going to have to be able to say. That's in quadrant 1, okay? Went to the right square root of 3. Who cares what the number is? It's not a perfect graph. Up 1, quadrant 1. So my rectangular complex number is in quadrant 1. It's right here. And you could make a right triangle out of it to help us find what we need. So think about it. What is R? It's just your hypotenuse, right? We need the R. That's one of the things we need. Well, we can use this to find that. R equals the square root of A squared plus B squared. Right? R is 2, always positive. And then we'll use our tan formula. Tan of theta equals y over x, sine over cosine, b over a, whatever you want to call it, there it is. Now listen, we have seen this fraction many times. We're seeing it again here in our notes. You'll see it again in your homework, the same exact fraction. You can either remember that this always simplifies to the square root of 3 over 3. I don't need to see this next step of work, but if you didn't memorize what this is, because it's such a common one you see all the time, you could rationalize the denominator, find that. Anytime you have 1 over the square root of 3, whether it's positive or negative, this is what it simplifies to. So I have tan of theta equals square root of 3 over 3. The question is, what is theta? So we know the denominator is going to be what? What's the denominator? No. There is no denominators of 9 on the unit circle. Okay, so denominator is 6. And again, remember how I talked about graphing this? You didn't need to graph this to know that our rectangular point is in quadrant 1. Well, that means theta is in quadrant 1. That tells me what numerator I'm going to use. Now I have r and theta, which is everything I need to write my final answer in polar form. Okay? So I'm going from rectangular form to polar form right here. Z equals r, parentheses, cosine of theta plus I sine of, I'm going to leave off the parentheses, it's just too crowded. That's it. So given A and B, finding R and theta, plugging it into the form. Okay? And I'll do one in the homework with you instead of doing another one in your notes. I'll do the first one in the homework with you. Okay? We have one last example, and these are your freebies as long as you know the unit circle. So the 2 homework problems you have today is going from rectangular to polar form, which I just showed you, and I'll do one more in your homework, or going from polar to rectangular. So even if I didn't see those directions, I can tell this is in polar form because I have thetas. Okay? And all you have to do to go from polar to rectangular form is plug in these 2 values and then distribute the 5. So in other words, we need to know the ordered pair, the cosine and the sine, for this angle. And using your unit circle memorization, we know that denominator is a 4, always have this ordered pair, right? Denominators are 4. 3 pi over 4 is in quadrant what? Quickly. 2. Numerator is 1 less than the denominator, that's quadrant 2. Cosine's negative, sine is positive. So you have to know that, and then the rest of it is just plugging it in. Cosine of 3 pi over 4 is negative square root of 2 over 2, right? That is that, plus I times square root of 2 over 2, which is sine of 3 pi over 4. Distribute, and that's your final answer. So these are a lot easier. It's so much easier to go from polar to rectangular than rectangular to polar. Z equals, this is 5 over 1, right? So that's negative 5 square roots of 2 over 2. Plus, and again, you can put the I anywhere you want. You can leave it in the front, you're not wrong, but you will typically see it after the radical in rectangular form. But again, you could have put the I in front of the 5, to the right of the 5. These are multiple choice questions on your test and your AP exam, so you wouldn't mess that up anyway, right? And that's it. So that's polar. I'm sorry, that's rectangular. A, B, A, B. Okay? Let's go to page 170. And I'm going to do number 1 with you. All right, so 1 through 8, cross out number 2. I'm going to do 1 with you. Okay, directions for number 1. Graph it, change it from rectangular to polar. Okay, it says express the argument in radians. Argument means your angle, or meaning just don't put your answer. You don't use we don't do degrees hardly ever in this class. Okay, radians only. So think about it. To graph this, before I even graph it, guys, what quadrant is this going to be in? This is a quadrant what angle? 1. This is quadrant 1. You have an A or X value that's positive and a B or Y value that's positive. To the right 2, up square root of 3. We are in quadrant 1. Let's call that point. 2, square root of 3, clearly not drawn to scale. But really great. They give you a multiple choice question where you have to graph a point like this. That's easy. The real reason we need to know how to graph it is knowing what quadrant it's in, because theta in a minute is going to be in that place. So I have A and B. I need R and theta, right? So R, think about what R is. R is just the hypotenuse. You're going to do Pythagorean theorem to get R. R is A squared plus B squared, and then find the square root of that, right? X, Y, A, B. We got R. And theta, I'm going to use my tan. Tan of theta equals B over A. There's a reason I'm doing this problem with you besides just to get you started, and that's because this is the only one in your homework where they didn't give us a standard tan. Listen, our only tan values on the unit circle are undefined or 0. Those are our quadrantals. 1, square root of 3, square root of 3 over 3. Those are it. Square root of 3 over 2 is not one of our standard angles. This is when we have to go to our calculator. So what you have to think of this is, guys, look, theta is inverse tan of this. So my point is, anytime you're trying to find a theta, you have to use the inverse button on your calculator. And be careful putting this fraction in. So I'm going to use second tan because I'm trying to find an angle. I use the inverse button. And I'm going to put in the square root of 3. But look, if I put it in like that, it's wrong. That is not the answer. We don't want the 2 under the radical. This 2 is not in the radical, right? So you just do square root of 3, and then if you just arrow over, you're out of the radical. But that would be easy to forget, because whenever you have to go to your calculator to find an angle, you're always going to get some crazy decimal, some irrational number. So it wouldn't be like out of the question to get a weird answer like that, and you might not pick up on it. But look at the difference in how they look typed in and 2 different answers. So be really, really careful. We always round to 3 places, so theta would be 0.714. Now we have everything we need to write our answer in polar form. R cosine of my theta plus I sine of my theta. There. Okay, so that's going rectangular to polar. So that's the only one in the homework that had a calculator one. The other one should be known angles, standard angles. So 2 more of those and then the easy ones.